Okay, so for our first lesson in chapter 2, we're skipping the first 4 lessons. You guys have already kind of reviewed those, and we're skipping right to lesson 5. Excuse me. So we're talking about postulates and paragraph proofs. Out of the 3 lessons that you're going to be doing this week, this is probably the least that I'm going to stress this lesson. As long as you understand the basic idea, that's the main point of this, okay? So we just went through the UNO example on what a proof is, a more formal 2-column proof. I do have notes for this. They look something like this. Instead of me just sitting here talking and filling out, because it's a lot of writing for these notes, I'm just gonna post my filled out notes on Schoology for you, and that way they're there in front of you. And if you wanna go back and write your own, great, I'm great with that. But I'm going to just teach you the lesson off of the study guide today. Okay, so this lesson is based off of the very first lesson we had in chapter 1, that points, lines, and planes. So we have a few, 7 rules that we're gonna start off with. These are rules. These are absolute rules in geometry. You are going to have to remember these. You are going to be using these for a while. So whatever your best way is to memorize rules, go for it, because you are gonna need to know these without looking at this little answer box here written out. You're going to have to be able to tell me, oh, that's postulate 2.5, right? Or, know what postulate 2.3 is. So it says, in geometry, a postulate is a statement accepted as true. So it's like a rule. That's all you have to know. Don't worry about the word postulate. It's just a rule. Postulates describe fundamental relationships in geometry. All right, so here's our 7 rules that we're going to start off with. Postulate 2.1, through any 2 points, there is exactly 1 line, right? Anytime you have 2 points, you can draw a line through them. So you need 2 points to draw a line. Can you draw a line through 1 point? No, you have to have at least 2 points. That's what this is saying. Through any 2 points, there is exactly 1 line. You can have more than 2 points, but you gotta have at least 2. Postulate 2.2, through any 3 non-collinear points, there is exactly 1 plane. So you're going to have the first 2 points always make a line, right? Doesn't matter where they are, you can draw a line between 2 points. But the third point can't be in line with the other 2. This is 3 non-collinear points. They are not in the same line. So whenever you have 3 non-collinear points, that makes up a plane. So that's rule 2.2. 2.3, a line contains at least 2 points. This goes with this guy. They sound similar, right? Actually, I get them confused all the time. It depends on which one you use, depends on the order of the problem that's given. And we'll get to that here in a second. I'll show you exactly what I mean. All right, postulate 2.4, a plane contains at least 3 non-collinear points. This one sounds like 2.2. Again, it's the order of how it says it. 2.1 says, through any 2 points, there's a line. So we're talking about the points first and the line last. Through postulate 2.3, it talks about the line first and the points. So we just flip-flop the order of what we're talking about. Here we're focused on the points, the little pieces that make up the line. Here we're focused on the line made up by the little pieces, right? Same thing with a plane. Up here we're focused on the points. The points are what's important, and they total up to be a plane. Here we're focused on the entire plane itself. That's what's important, and it's made up of at least 3 non-collinear points. They're saying the same thing, but the order in which they're saying them matters. All right, 2.5 to 2.7 don't have any confusing things like that. 2.5, if 2 points lie in a plane, the entire line containing those points lies in the plane as well. 2.6, if 2 lines intersect, then they intersect at a point, right? If I had an X, right where they cross is 1 point, that's all that rule is saying. And then 2.7, if 2 planes intersect, here we have lines intersecting, when 2 flat surfaces intersect, their intersection is a line. So 2 lines intersect in a point, 2 planes intersect in a line. And then 2.5 up here, if there's 2 points on a plane, then the entire line containing those points on a plane is in the same plane. So think about if you were here in class and I was drawing on the whiteboard and I put 2 dots, right? Those 2 dots. Those 2 dots are in a plane. So I'll just kind of draw, oh, there's the bell. This is supposed to represent a flat surface. The flat surface would be the whiteboard, or right now my sheet of paper. So these two dots are on the same flat surface, and I can draw a line through two dots. So the line through those two dots is also in the same plane as those two dots, right? Seems like it's crazy whenever we have rules for this stuff, but it is true, and it is something you're gonna have to know. All right, so those are our 7 rules. They're on this paper. This paper is on your, on Schoology here, so you can pull that up. All right, example, determine whether each statement is always true, sometimes true, or never true. And I started filling them out. So they gave you a few examples. There is exactly one plane that contains points A, B, and C. That's sometimes true. Why is it just sometimes true? If A, B, and C are collinear, then they are contained in many planes. If they are non-collinear, then they are contained in exactly one plane, because 3 non-collinear points make up a plane. A line can be contained in any plane, but 3 non-collinear points make up their own plane. So this is sometimes. B, points E and F are contained in exactly one line. That's always true. Through any 2 points, you can draw one line. Now look at the wording of this. The first thing we're talking about is points. Points E and F. The last thing we're talking about is the line. We weren't talking about the line and then the points, it's the points and then the line. So up here, out of 2.1 and 2.3, 2.1 talks about points and then a line. 2.3 talks about a line and then the points. So the reason behind this rule right here, the reason why this is always true is because of rule 2.1. Points E and F are contained in exactly one line. There it is again, tardy bell. Because through any 2 points, there is exactly one line. The first postulate tells us here. All right, C, 2 lines intersect in 2 distinct points, M and N. That is never true. What did it tell us about when 2 lines intersect? Up here, postulate 2.6. If 2 lines intersect, their intersection is exactly 1 point. If 2 lines intersect, they cannot have 2 points. It's just 1 point. The intersection of 2 lines is 1 point. All right, so then we start filling out the bottom here. I did the first few. You can go on and try and finish them up yourself. A line contains exactly 1 point. Up here, the rules about lines and points are 2.1. Here, I'll put a little square around them. And 2.3. Okay, now the wording on here, and I put the wrong one down, the wording on here is a line first and then points at the end. Oh, sorry, never mind, just kidding. It's never true anyways, sorry. A line contains exactly 1 point. A line contains 2 points, and it tells us up here in 2 different rules. Through any 2 points, there's a 1 line, or a line contains at least 2 points. So since this says a line contains 1 point, and rule 2.3 says a line contains at least 2 points, 2.3 would be the reason why this is never true. It contradicts it. There is a rule that directly corrects that statement. Number 2, non-collinear points R, S, and T are contained in exactly one plane. So we're talking about points being in a plane. And we've got 2 postulates up here, 2.2 and 2.4, that talk about planes and points, right? So ours have to talk about the points first and the plane at the end. 2.2 talk about the points first and the plane at the end, right? 2.4 talks about the plane first and then the points. It's in a different order. It says the exact same thing, just the way it's written. We want points first and plane at the end. So 2.2. So non-collinear points R, S, and T are contained in exactly one plane. That's always true because of rule 2.2. And number 3, any 2 lines, L and M, intersect. Well, sometimes they do, right? You can have 2 lines that cross. They look like an X, right? L, M, they cross each other. They form a point, right? But sometimes, what if they're parallel lines? If they're parallel lines, they won't always intersect. So that's sometimes true. It's not listed in one of our rules up here, but we can give an example, like parallel lines. They don't intersect. So sometimes this is true. Number 4, if points G and H are contained in plane M, then line GH is perpendicular to plane M. And we have a rule that tells us something completely different, right? Rule 2.5 says if 2 points lie in a plane, it says if G and H are contained in a plane, then the entire line containing those points lies in the plane. This says then the entire line containing those points, line GH, is perpendicular to the plane. So that's not true. It's not perpendicular. That's never true, and that's rule 2.5 that tells us otherwise. Okay, let's finish it up real quick. 5, planes R and S intersect in point T. What did we learn about planes intersecting? Their intersection is a line. So 2.7 tells us when planes intersect, they form a line. They intersect at a line. Planes R and S intersect in a line. So that's never true. Rule 2.7. And 6, if points A, B, and C are non-collinear, then segments AB, BC, and CA are contained in exactly one plane. Yes, that's actually 2 rules. That is always true, right? If points A, B, and C are non-collinear, then they're contained in exactly one plane. Points being in a plane is up here, postulate 2.2. Any 3 non-collinear points, they're in one plane. So that's 2.2. And then the line segments created from those 2 points are also in the same plane, which was if 2 points lie in a plane, then the entire line containing those points lies in the plane. That was postulate 2.5. So hopefully that kind of makes sense how we're using the rules to prove these things true. We are eventually going to use these rules in proofs, but right now we just want you to get familiar with them. In the figure, AC and DE are in plane Q, and AC is parallel to DE. State the postulate that can be used to show each statement is true. 7. Exactly one plane contains points F, B, and E. Here's point F, here's point B, here's point E. Now, point F, see how the bottom is dotted? That's trying to show, remember when I talked to you about the tabletop, like if you had a table outside and it's got an umbrella, oops, let me draw that there, and it's got an umbrella coming through it, right? That umbrella is not on the same flat surface. It's actually cutting through that flat surface. That's what this dotted line is supposed to show. This line here is not on the same flat surface as our plane. It's actually cutting through it. But it doesn't matter because our rule said that any 3 non-collinear points, any 3 dots that are not in the same line, create their own plane. So F, B, and E would create just a whole nother flat surface right there connecting them all. So that is true, and we have to figure out which rule proves that. So one plane contains 3 points, and those points are non-collinear. We can look on the picture. So which rule says that about a plane contains 3 non-collinear points? 2.4. A plane contains at least 3 non-collinear points. 2.4. And then number 8, line BE lies in plane Q. Well, here's point B and here's point E. Through any 2 points, I can draw a line. Since points B and E are both in plane Q, then the line going through them is also in plane Q. So I have 2 postulates here. The first one is through any 2 points, I can draw a line. Through any 2 points, that's 2.1. Through any 2 points, there's exactly one line. 2.1. And then the one about if 2 points lie in a plane, then the entire line containing those points lies in the plane. 2.5. So hopefully going back and forth, looking at them a bunch helps you kind of clarify and understand, okay? All right, lastly, I'm just gonna give you a situation where we can write a paragraph proof. I was going to go over the examples on the back of the 2-5 study guide, but they end up being a little too complex, and I don't want to focus on that. I don't want to spend too much time on paragraph proofs. As long as you get the gist of it, that's the point. So here I have started off with an equation. This is my given, 2x plus 4 equals 14. And then I have to prove that x equals 5. So So basically all I'm doing here is solving for x. I just have to write it out in a proof form, okay? So I start off with line 1, 2x plus 4 equals 14. That's my given. Line 2, what's the next thing I have to do to solve for x? I got to get rid of this 4, right? So to get rid of plus 4, I subtract 4, and whatever I do on one side of the equal sign, I have to do to the other. So this is my step 2. And why did I do that? What's my reason? Why did I subtract 4 from both sides of the equal sign? Because of the subtraction property of equality. And we're not focused on that. We actually are going to get into algebraic equations, algebraic proofs in the next lesson. But here I'm just showing you the logical progression so that we can put it into a paragraph. Okay, so I subtract 4 from both sides. Then I simplify. So once I subtract 4, I showed that I did it here. Then I went ahead and did it in the next line. So these 4's went away. 14 minus 4 is 10. So whenever I substitute numbers in place of values that they're equal to, that's substitution. So I'm writing out the property and then I'm simplifying, substitution. And then the next step would be to get rid of this 2. So I have to divide both sides of my equal sign by 2. That's the division property of equality. And then after I divide, I simplify. And that's substitution once again. So these are my steps. This would be a proof, a 2-column proof. But I don't want a 2-column proof. I want to write a paragraph proof. So how can I use this information to do that? All I'm going to do is go line by line and write a few sentences. So I'm going to start with line 1. Given that 2x plus 4 equals 14, given that 2x plus 4 equals 14, and honestly, you should have proper grammar and everything here. You're writing a paragraph, but I'm not focused on that. We're doing math. As long as you understand how to write a paragraph proof, I'm not going to get too strict on grading your grammar in this. So given that, first line, given that 2x plus 4 equals 14, I'm trying to solve for x, so I can say to prove that x equals 5, I first subtract 4 from both sides of the equation. And what's the reason? Because of the subtraction property of equality. So I'll say because of the subtraction, and I'm going to abbreviate. Please do not abbreviate, just for the sake of the video, I'm abbreviating. The subtraction property of equality. Okay, so that's my first 2 lines. Once I simplify, because the next line is substitution, I simplified line 3. So in my paragraph proof, I'll just kind of summarize that. Once I simplify, what's the next thing I have to do? Divide both sides of the equation by 2. I will divide both sides. Don't just say both sides. You have to tell both sides of what? Both sides of the equation by 2 because of the division property of equality. Again, I'm abbreviating because of just the sake of time, but please, when you're writing out your answers for me, don't abbreviate. Okay, so then we just did this. And then when I simplify, I get x equals 5. When I simplify, I find that x equals 5. Or maybe a better thing to say would be I can prove that x equals 5. I can prove that x equals 5, okay? That's a paragraph proof. We just wrote it out in sentences. The exact thing we showed up here, these logical steps, line by line, that's what I did here. Given that 2x plus 4 equals 14, to prove that x equals 5, I first subtract 4 from both sides of the equation because of the subtraction property of equality. And then once I simplify, I'll divide both sides by 2 because of the division property of equality. Once I simplify that, I prove that x equals 5. Done. Paragraph proof, done. If you guys have questions on kind of that logical progression, let me know. But the basic idea is that you can write a proof and then you can summarize it in a paragraph or a few sentences.